So my OpenSIM is on, and right now what we can do is we need to install the plugin. So here is the plugin, nslr.dll. Click on it and then select this and click OK. The next time we start OpenSIM, it will be loaded automatically into the platform. So let's see how do we extract motion data, I mean the motion files from gate data that we extract from GitLabs. So let's do a small tutorial on that. I'll just redirect to myself to the folder. Let me check if the recording is happening properly. Yeah. So the data that we get from GitLab is in the form of C3D file. As you can see, these are the C3D files. C3D files. Just shift to normal layout. Now what you can do is let me minimize OpenSIM for some time. Right now, in order to see this files, I mean read these files, we need a third-party software called Mocha. Here it is. So let me load the files here. Say, let me load walking. This is the complete activity of walking, as you can see. So my what you can do here is I mean, crop the window at number of frames that are required for our activity. So I'm just gonna take it till this point. So it's one stride, right stride, sorry, left stride followed by right, left, right, and then left till the heel strike. Okay, let me play it once. So this software is quite helpful because we can visualize a lot of information from it. For example, the force that is being shown in the force plates. You can see it here. This is an x-axis, y-axis, and z-axis. Followed by that, what you can do is, in order to export the kinematic marker positions, we need to export it as .trc. So here it is, trc file. Before that, there is a very important point that we should keep in mind, that is the name of the markers here should be the same as that of, let me load a model. This is the model. The name of the markers in this model and the one that is here in the data should be same, should be identical. Let's click on this. So this is C7, C7 are showed, as you can see here. Let me put it in side screen so it's visible properly. All of them are of the same names. Nomenclature has to be the same in both the cases. So let's export the file. So let's export the trc file. Let's name it as walking s1t1. Another important point that has to be kept in mind is uh, this model, this OpenSim musculoskeletal model has to be uh, scaled to the geometry anthropometric data of the subject. So for that, what we do is we use the standing.c3d file and extract the limb lengths and everything. So let me load that file here. So I'm going to take the whole thing and export it as C3D, sorry, not C3D, file, export it as .trc, standing s1, and let me save it as the same. So in order to do that, let's go to OpenSim, let's go to tools, followed by scale model. Here the mass of the subject has to be specified. So let's say it's 72 in our case. Preserve the mass distribution, marker data for measurement, standing, okay. So this is also standing, okay. And then click on run to, we can change the scaling factors for all the rigid bodies that are being used in this musculoskeletal model. So these are the options here, and just click on run to scale the model. I've already done it. This is already a scaled model of the subject, so I'm just gonna skip this step. So now let's extract the kinematic data. I mean, let's convert the .trc kinematic data into a motion file that can be used for further analysis in OpenSim. So let's go to tools, click on inverse kinematics, marker data for trial, click on that. This is the marker data. Let's click on OK, and let's hit run. So in this step, basically the inverse kinematic toolbox is reducing the squared error between the markers to, and by minimizing the squared error between the markers, it is calculating the joint angles using inverse kinematics. So this is how the whole thing is taking place. So this data that we collected will have some crosstalks in it, high frequency crosstalks that can be filtered in later stages of the analysis. So let me pause the video right now because it's going to take some time.